Well, hello. I'm going to walk through today's notes with you. I am doing it here from my home, so you're going to get a picture of the screen today. I'm going to talk through a couple details. I know we talked about just understanding where it is we're headed, and just to give you, for those of you who especially like this, the way we talked about, today when you're in class, we're going to go ahead and solve quadratic application problems, but today we're going to specifically do it by graphing. You're going to want your calculator, so take a minute and get it out. You can hit pause if you want to. And when we're done, your homework is going to be the worksheet that you picked up yesterday. So there are only 5 problems. I'm going to talk through how to best go about this in the next couple days here at the end of the video. To begin with, these are from the notes that you picked up off yesterday's shelf. I'm just going to read this out loud. A flea's jump can be modeled by the function y equals negative 0.073x times x minus 33, where x is the horizontal distance in centimeters and y is the corresponding height in centimeters. How far, there's my puppy, sorry about that. How far did the flea jump? So that's going to be question number 1. And question number 2 is going to be how high was the flea at the top of its jump? So what I want you to do is go ahead and go to your calculator and start to put this in. Go to your home screen, and I'm just going to do a new document, and I'm going to add a graph. And I'm going to have you go ahead and hit pause, because what I've done is, just for time's sake, so that you can get the most out of this, I've included on the next slide the actual graphs. So go ahead, and I want you to be able to follow along on your calculator. Get that in there, and then we'll talk through what you're looking at. Okay, so at the top on this slide right here, sometimes what happens is when you put anything in your calculator, the calculator will by default give you this window from negative 10 to 10, and sometimes it goes negative 6.67 to 6.67. It has a tendency to have that be the default. So you're going to start to just know some information just by looking at the equation. First and foremost, you would tell me this is facing down. It's a let me say it this way, sorry. First and foremost, you know it's a quadratic because there are 2 x's, which therefore means if I were to expand it, I would have a power of 2. So the one thing you might want to just simply add to your notes is that what matters first is that this is a quadratic. Secondly, because of this coefficient here being negative, I know that it is a parabola facing down. A parabola opening down. So I don't have to have a perfect picture to at least know I'm doing this, right? I may not be able to do anything else at this point, but notice that I can do that. Now, what I want to then do is be able to look at this equation and say, okay, well, what else do I know? Well, ideally, I recognize this is in factored form. And in factored form, what that means is if I wanted to quickly find the x-intercepts, and you should hear the phrase intercept form in this, I could set f of x equal to 0, which is really code for y equaling 0. And I could say, hey, look, I've got negative 0.073 times x minus 33, but I know from our quiz that if I have a quadratic set equal to 0 in factored form, I know this will never be 0, but I could set my little pieces, my little factors equal to 0, x equals 0, x minus 33 equals 0. So I can therefore conclude that either x equals 0 in this equation to cause 0 and x equals 33. Well, now my quadratic, even just in my head, is taking on a more concrete shape, because now I know it goes through 0 and 33. So we're going to do this here. Now, what that actually then I can start to do with that is actually draw some pretty concrete conclusions. For example, the problem tells us that x, and it walks through this for you, it says x is the horizontal distance and y is the corresponding height. So what this tells me is that if I want to talk about my horizontal distance here, and this is my height here, right? My horizontal distance is here, and my height is here. Well, if I am asked the question, and I'll try not to make you car sick going up to this, if I have to ask the question, how far did the flea jump? Well, that is how far as a horizontal distance. So I can answer the first question on that slide of the notes. How far? 33 feet. I haven't done anything yet in my calculator. Anything at all. So now I'm going to go, and again, for time's sake, and I can always go over this with you tomorrow, I'm just going to show you here on a basic quadratic, and then you can start to try it. We're going to start to look at, well, then how do I find out the answer to the question, how high? Because that obviously matters. So my laptop here is doing a couple of funky things. So I'm going to put in the equation, but you go ahead and what I want you to do is, if you remember how to, if you remember how, there we go, sorry for the delay, how to find the maximum, go for it. If you don't, I'm going to actually do that for you right here, because I just want to make sure you know the keystrokes. Notice again, just by putting it in, I have this picture that almost looks like a line. I have to know, as the person doing this problem, that this is a quadratic. I have to know in advance. I'm going to go ahead and expand this to 37. I don't know how high, but look, do you see how the maximum is clearly here somewhere? So what I'm going to do is hit Menu, Analyze Graph, choose the maximum, and you can always rewind and watch this. Then I'm going to take that vertical line, I'm going to get to the left, then I'm going to move this to the right, and you'll notice that the calculator already knows to take on the duty of finding that maximum. So that maximum is 16.5, 19.9, 16.5, 19.9. This is a horizontal distance, this is a vertical distance. 16.5 feet across this way gives me a maximum height of 19.9 feet. So in answer to the question, and I said feet, it should be centimeters, my apologies. How high? The answer to that question is 19.9 feet. On your notes here, I would sketch a graph, and if you notice, as you play with the different settings, you can actually really notice that if I go ahead and get that to the height of, or to a maximum here of 30, I can actually increase how high I can see it. I can actually see that full vertex, and then I can answer the questions. Okay, so we're going to actually, that's the key to what you're going to do in this homework, because the truth is, tomorrow we're going to actually talk through these remaining two together. So your job today is to take this information and go to the homework. So I'm going to pull that up so you can see it here. And if I see it, so let's try again. And by see it, I mean you're going to watch me click through my computer. My apologies. Okay, so at the top of the homework that you picked up off of yesterday's shelf, it says Quadratic Applications homework. And notice that you're given an equation this time that's a little bit different. So it says solve each problem by graphing. Your job is going to be in a minute here to set up the equation. And then you're going to use your graphing device to graph the equation. You're going to find the solution for whatever question is asked. So notice in the problem we just did, you were asked to find how far or how high the flea went. Well, in this case, in a minute, we're going to talk about a volleyball player. And then you're going to draw a sketch of your graph, labeling the important points where you found your answers. So notice on my graph, I'll go back to it here for a second. On my graph, I labeled the x-intercepts to give the horizontal distance. I labeled the vertex to give the height. Finally, write your final answer as a sentence. So listen to how we'll do this first question together. A volleyball player spikes the ball over the net when the ball is 9 feet above the ground. She hits it with a downward velocity of 40 feet per second. How much time does the opposing team have to respond before the volleyball hits the ground? So as a reminder, you're given at the top of the homework page that that is my sweet little puppy who wants to be pet. The height is given according to also the time and velocity. So what we can do is say, oh, well, this is going to be negative 16t squared plus the velocity, I'm sorry, plus 40t, and then plus my initial height of 9. Yep, I'm sure this is a really good video at this point. Okay, so I'm going to go ahead and we're going to call it, and you're going to plug those values in. You're going to plug in 40 for velocity, you're going to plug in 9 for initial height, and then you're going to go ahead and go through the exact same process that we went through for the fleet. So one other quick reminder, your 2 graphing worksheets should be completely attempted. Tomorrow we're going to spend the first part of the period for the most part just answering homework questions, and we're going to do the remaining 2 problems that are here in your notes just to do some together and to continue to have this bigger conversation about quadratic applications. This is by far one of the more useful aspects to quadratics is looking at how they can be used to answer questions. So do me a favor, just make sure I kept this video short for a reason, so you would have an opportunity to plug in, to actually do the work for these 5 problems, or to have some time to finish up perhaps the 2 graphing worksheets that we did earlier this week. So I will see you tomorrow, and I'll answer your questions, and we'll continue to talk to about quadratics. I bet that sounds super exciting. Okay, see you tomorrow.